Now we are going to discuss question number 5. In question number 5, it says state the number of planes of symmetry and the number of axes of rotational symmetry for the following solids, which means we do not actually have to mention the order of rotational symmetry in these 3D shapes. We only have to mention the axis of rotational symmetry and the number of possible planes of symmetry. The first shape is a cuboid. This is what a cuboid looks like. We all know that a cuboid looks like this. We all know that already. Okay, so right now I am going to discuss the planes of symmetry in these 3D shapes, starting with the first part, that is the cuboid. We can draw them and we can obviously also now place the planes of symmetry. The first plane of symmetry that I am going to place here is this one, entering from the top till the bottom. This is how it will look like, from the top and to the bottom. At the same time, this is also a plane from not just from the top to the bottom, this is also from the front till the back. So you can see this is one plane of symmetry in a cuboid, and this is how it will look from that side. This is the first plane of symmetry, from the top till the bottom or from the front till the back. After this plane of symmetry, there can be one more plane of symmetry, and that will be this, entering from this side, midpoint center of this side, to the midpoint of the other side. This is how it will look like to you, and if you look at it from the top, it will look like this. From this side it will look like this, and from there it will be like this. So there have been two planes of symmetry, one entering from the top and coming out at the bottom, or maybe from the front till the back. This was one plane of symmetry. The other plane of symmetry was from here till here, or at the same time from this side to this side. These are two planes of symmetry now, and the last plane of symmetry is going to be from this side to its opposite side. So we can say there are going to be three planes of symmetry in the case of a cuboid. That one will be this will be the first one. This is the first one. This is going to be the first one. The second one is going to be this. This is the second plane of symmetry, and there it is. Here is the third plane of symmetry. I obviously cannot insert all of them at the same time. I only have cuts one at a time. So this is the first plane of symmetry, this is the second plane of symmetry, and this is the third plane of symmetry in the case of a cuboid. And when it comes to axis of rotational symmetry, so axis of rotational symmetry will also be three. One from the center of the top till the center of the bottom, like this. This will be the first axis of rotation. The second axis of rotation will be from this side to the midpoint of this side. Okay. So there have been two. One, this is one, this is two, and this is going to be the third one. So these are the three planes, axis of rotational symmetry, and those were the three planes of symmetry which I discussed earlier. Okay. Now next shape is a cube. This is what a cube looks like. This might irritate you the most. The first one is going to be from the back to the front, and at the same time from the top to the bottom, from back to the front. Okay, and at the same time from top to the bottom. So the first plane of symmetry is going to be this one, from back to front and top to bottom. This one is there already, and then when this is done, so after this there can be one more from this side to this side, like this one, from this side to this, and that is how it is going to look like. Okay, so back to front, left to right, these are the two, and then there will be one more horizontally in this way. I cannot see the video, so I really hope that everything is properly visible. So we have three planes of symmetry right now. This is the first one, from back to front, then this is going to be the second one, from left to right, and then this is the third one, from back to front or left to right but horizontally. These are three planes of symmetry from one surface to the other surface. Three are already there, and there are actually 9 planes of symmetry in a cuboid. So one more plane of symmetry is going to be, where is it? Yes, here is it. Here it is, and yes, this is the one, and for this I have a different color sheet. This one, from one edge to the opposite edge. So from back top to the front bottom, and in the same way from front top to the back bottom. These will be two more, from here to here. Let me draw this. This is going to be the first one, like this, from this side to this side, and then one more from this side to the other side, like this. Okay, so from this side to this bottom, and then from this top to the rear bottom. This will be two more, so I have 5 up till now. From one surface to other surface, I told you, from one edge to the other edge, and then there are edges on this side and this side as well. So there will be one more plane of symmetry in this direction and one more plane of symmetry in this direction. So that gives us 2 more, that makes it 7. I can do it for you from one side to the other side, like this one, and then like this as well. So we have 7, from one surface to the other surface, front to back, left to right, and then from front to back and left to right in the horizontal way, and then from one edge to the other edge, from the back top to the front bottom, then from the front top to the back bottom, and then from this side to this side, this to this. So from edge to edge, how many? 1, 2, 3, 4. These are 4 more. Then I had 1, then I had 2, and then I had 3 more. These are 7 up till now. Now there are 2 more planes of symmetry missing. Which are those? They are going to be like, where should I insert it from? Okay, they are going to be like this. I hope I'm not mixing up anything. From this edge to this edge, 8, and then from this edge to this, that is the 9th. I hope this all is clear. Let me sum it up one more time. From this side to this side horizontally, from this side to this side vertically, and then from this surface to this surface only vertically, because horizontal is the same. These are 3, from one surface to another surface. Then from edge to edge, this and this one, then this one, and the bottom edge, this is the 5th one. From this edge to this side's edge, 6th, then 7th, and then this 8, and then this is the ninth one. So these are 9 planes of symmetry in a cuboid. Then